All right, I'm going to try to get an early start on this. Geometry, lesson 65, distinguishing types of parallelograms. Now this should be a repeat on your four properties, or really what we've looked at in previous lessons. Even lesson 61 presented several methods for determining if a quadrilateral is a parallelogram. The properties in this lesson make it possible to determine if a parallelogram is a rectangle, a rhombus, or a square. Now, by definition, all rectangles are parallelograms, all rectangles are parallelograms, all rhombuses are parallelograms, all squares are parallelograms, but not all parallelograms are rectangles, not all parallelograms are rhombuses, not all parallelograms are squares. So we're going to determine if a parallelogram is one or more of these three things. Now, obviously, anything that is both a rectangle and a rhombus is a square. So in this lesson, what we're going to be looking primarily at is a parallelogram a rectangle? Is a parallelogram a rhombus? And if it is those two things, then we can be more specific and say that it is a square. So we're going to look at about four or five different properties of parallelograms and how they relate. So here we see if an angle is a parallelogram. If an angle in a parallelogram is a right angle, then the parallelogram is a rectangle. So all of these are going to be parallelograms. All five of these are going to be parallelograms, and are going to be indicated as parallelograms by the fact that we're going to see opposite sides are parallel in all five of these examples. And so then we're just going to be looking at one specific thing that's going to make it a rectangle or a rhombus. In this case, if I have just one angle in this parallelogram that is a right angle, what that's going to force, it's going to force all four right angles to be right angles, therefore making it a rectangle. So, but I only need one for that to happen. So in this case, because angle B is a right angle, ABCD is a rectangle. So we're looking for kind of the least common denominator. What is the smallest amount of proof that I need to prove something? In this case, if I know it's a parallelogram and I have one right angle, we know that it is a rectangle. Okay. This one's going to talk about is a parallelogram a rhombus? If consecutive sides. Okay, consecutive as opposed to opposite sides. If I have consecutive sides that are congruent, then the parallelogram is a rhombus. Because WZ is congruent to ZY, it's a rhombus. We also could have said, hey, if I know that WX is congruent to XY, then I know that it's a rhombus. Okay, there's a couple of different ways, but really we just they're leaving it as broad enough and as specific enough to say consecutive sides. If consecutive sides in a parallelogram are congruent, then the parallelogram is a rhombus. Okay, coming back to rectangles, if the diagonals of a parallelogram are congruent, then it is a rectangle. All right, if you remember back in our rules of rectangles, basically we said, if it is a parallelogram and the diagonals are congruent, then it is a rectangle. So this is just that over again. We can see that it's a parallelogram because opposite sides are parallel, and we see that the diagonals bisect each other, but also that the diagonals are congruent because all four diagonal segments are congruent to each other. So since AC is congruent to BD, we know it's a rectangle. Okay. All right. Back to a rhombus. If my diagonals are perpendicular, then it is a rhombus. Okay. If the diagonals of a parallelogram are perpendicular, then it is a rhombus. And finally, if a diagonal in a parallelogram bisects opposite angles, then it is a rhombus. Okay, and these are all rules that we've looked at before. So, if I know that all four of those are congruent, okay, they're bisected, which means I'm working with a rhombus. Okay, so let's start looking at some of the lesson work here then. All right, and they're going to put this in a sort of a proof form. It says determine if the conclusion is valid. If not, tell what additional information is needed to make it valid. So they tell me that AB is congruent to CD. So let's use a tick mark here. Okay, we've got congruent statements there, and then they tell me that BC is congruent to DA, and they tell me that AC is congruent to BD. So we get something like this. Okay, if that makes sense. Okay. All right. If not, we need to determine what information we have. Okay. So we see that, and let's be more specific here. We know that opposite sides are congruent. So we're not saying that AB is congruent to AD, we're just saying that AB is congruent to CD. So we do have opposite sides are congruent. In a parallelogram, opposite sides are congruent. So if I have a quadrilateral where opposite sides are congruent, then I know it's a parallelogram. So far that matches up with A as an answer. So we know we're working with a parallelogram. We want to be able to prove that this is a square. So for us to prove it's a square, we have to be able to say, point to a rule where we know it's a rectangle and a rhombus. So if you look at this, we see that the diagonals are congruent. So because the diagonals are congruent, we know that ABCD is a rectangle. All right, we can go back to our properties of parallelograms and see that. All right, but two consecutive sides are not known to be congruent. So ABCD is not necessarily a square, and mainly it's not a square because we can't prove it's a rhombus, right? I can't say that AC is perpendicular to BD. I don't have enough proof for that. So I don't have a diagonal rule. I don't have an angle bisector rule. I don't have consecutive sides to go on. So I can't say that this is a square, even though it looks like it. Okay, and that's important as we've looked at this stuff and talked about it before, that we can't make assumptions based upon appearances because even the smallest difference can keep it from being what it looks like. Okay, so A is my answer here. Okay, I do not have enough information to show this as a rhombus, therefore I cannot make the assumption that it is a square. Okay, let's clear that out and come down to this next one. It says, which of the following is the most descriptive name for figure MNOP with vertices at these points? Okay, so what I'm going to do here is I'm going to go to something like this, and we're going to look at those points. So the coordinates that they gave me were -3, 5. We had 0, 9. We had 4, 6. And we had 1, 2. So let's plot those. -3, -3, 5. 1, 2, 3, 4, 5. So it should get me a point right about there. Okay, we had 0, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right there. Let's see, we had 4, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay, and 1, 2. Okay, so we've got something that looks like this right here. Now, we want to determine what this is. And now we've seen this before. I've showed you this before. This is where you want to get a sheet of graph paper and you want to show as much work as possible. All right. If this, we need to be able to say at least that, let's say that it's a parallelogram. In order for it to be a parallelogram, we either need, our opposite sides to be parallel, or we need our opposite sides to be congruent. So what I'm going to do is this. I'm going to, I think it's the quickest way, 1, 2, 3, 4, 1, 2, 3. Okay, so I got 4, 3, which if you remember your Pythagorean triples means that this side is 5. 1, 2, 3, 4, 5. Sorry, 1, 2, 3, 4. 1, 2, 3, so that's 4 and 3, which means this is 5. 1, 2, 3, 1, 2, 3, 4, 4, 3, which means that side's 5. 1, 2, 3, 1, 2, 3, 4, which means that side's 5, which means all 4 sides are congruent. Okay, so I can say, I can say that this is a rhombus because all 4 sides are congruent. Okay, I can also say that it is a parallelogram because opposite sides are congruent. So because, let's see, let's label these again. Negative 3, 5, this was M N O P. So because because MP is congruent to NO and MN is congruent to PO, I know it's a parallelogram because it's quadrilateral with opposite sides congruent. I know it's a rhombus because all 4 sides are congruent. The next thing I need is to prove that it is it's a rectangle. So we can do that by any number of ways. Okay. The way I'm going to choose to do it is I want to look at the diagonals. Okay, so I want to look at that right there. Okay, again, I'm going to look at it in terms of a right triangle. So it's going to go over 1, 2, 3, 4, 5, 6, 7. Okay, so it's going to have 7, 1. So 7 squared plus 1 squared equals c squared. So I got 49 plus 1 equals c squared. It's 50. So I'm getting square root of 50 is the length of that diagonal. So MO, and we could probably simplify that, but all I really need to know is NP the same length? So I'm going to go down 1, 2, 3, 4, 5, let's see, 1, 2, 3, 4, 5, 6, 7, okay, and over 1. So it appears to have the same distance, okay, which means, okay, it is a rectangle because the diagonals are congruent to each other. So because it's a parallelogram, all right, I could have circled A, but then we went further and we said it's a rhombus because all 4 sides are congruent. And then we went a step further and said, well, it's a rectangle because diagonals are congruent, because it is a parallelogram, a rhombus, and a rectangle. We're going to go back over here, and we're going to say it's D a square. Okay, but I have to have proof. Okay, that's what I'm trying to show you on this stuff. You guys are struggling with your test because we're struggling to show proof. Okay, we have to be able to show proof. Okay, let's come down to our next question. Okay, the sides of a wooden chest. The side of a wooden chest is quadrilateral AB. So they've shown me that AB is parallel to CD. Okay, so I'll use those arrows to denote that they're parallel, and BC is parallel to DA. Okay. Measure angle A is 90 degrees. What is the most accurate description of ABCD? Well, we know it's a parallelogram because opposite sides are parallel, and we can say that it's a rectangle because if I have a parallelogram with one right angle, then it is a rectangle. So we'd look at A for this. Both pairs of opposite sides are parallel, so it's a parallelogram. Since one angle measures 90 degrees, it's a right angle, and a parallelogram with one right angle is a rectangle. So that's how we get A for that. But first we draw our picture and we see that. Okay. All right. Is this a rectangle? Okay. Well, notice first it says it's a parallelogram. Okay. So we know that AD must be parallel to BC. We know that AB must be parallel to DC. They're telling me that what I have here is I have alternate interior angles are congruent, right? Because what I have is I have parallel lines cut by a transversal. Okay, so that's going to show me that. But also, I have this right here. So I know that these are congruent. Okay. Let's see if I've got enough information here. Okay. So I actually went back, you noticed that I paused it and then I erased some things and rewrote some things. And I kind of had to get my brain wrapped around it for a second. So the biggest, most important word in this is that it is a parallelogram. So everything that applies to a parallelogram is true here. And so, taking that in mind, we should know that opposite sides are congruent. So AB is congruent to DC. And you notice I drew some extra lines. So one of the things I ended up saying is that because AB is parallel to DC, that makes AC a transversal. And they already showed me that those alternate interior angles are congruent, which is this angle right here and this angle right here. And then I drew this red line through it and gave you these tick marks because BD is also an alternate set of angles. And then of course we know that that these green angles are congruent because they're vertical angles are congruent. So because what I have here is I know that these two triangles, this one here and this one here, are congruent to each other because of angle, 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 side. Okay, we have an angle, 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 side congruency postulate. And what's interesting about that is that now that I know that these two triangles are congruent, corresponding parts of congruent triangles are congruent. So what I know is that this length right here, DE, has to be congruent to BE. And I know that this side right here has to be congruent to this side right here. Okay, and because the diagonals are congruent, then we know that this is a rectangle. So this actually takes quite a bit more knowledge. You actually have to go back to, parallel lines being cut by transversals, go back to lesson 12 with your alternate interior angles being congruent, CP, your corresponding parts of congruent triangles are congruent, and then putting in your tick marks as you go, also remembering all my properties of parallelograms where opposite sides are parallel and opposite sides are congruent. Okay, so all of that is necessary information to take what they give you there and get to where you need to be with being able to say that that's a rectangle. Okay, number 5, is the parallelogram shown below a rectangle? Okay, well, if this is a parallelogram, then both these angles would have to be equal to 90. Okay, which means they would have to be equal to each other. Okay, so what I can do is I can actually solve one of these for 90. 11x minus 9 equals 90. Okay, we'd add 9. Okay, we get 11x equals 99. We divide by 11. We'd find out that x equals 9. And then we want to take that 9 and plug it back in over here. So 9 times 9 plus 9. Does that equal 90? Well, 9 times 9 is 81. 81 plus 9 equals 90. Because both those angles using the same x would equal 90, then we would say, yes, this is a rectangle. Okay? But both of them have to equal 90 degrees. Okay, the same x has to work for both. And you could have done it the other way around. You could have said 9x plus 9 equals 90, subtracted 9, got the 81, divided by 9, got x equals 9, and plugged it into the 11x minus 9. Either way would work. But my answer there is yes. Okay, number 6, we're getting towards the end. Is this parallelogram a rhombus? We haven't seen a lot of rhombus questions up to this point, But if you'll remember in our properties of parallelograms that we want consecutive angles to be congruent, okay, so what we would have to say is 5x minus 4 equal to 11. Okay, so we're going to solve for x. We're going to add 4, so we're going to get 5x equals 15. We're going to divide by 5. We're going to get x equals 3. So then we want to plug that back in. Does 5 times 3 minus 4 equal 11? Well, 5 times 3 is 15. 15 minus 4 is 11. 11 equals 11. So yes, consecutive sides are congruent. So yes, that's my explanation. It asks for an explanation, we need to give an explanation. That is it. All right, number 8 is this a rhombus? Same principle, okay? Exact same thing. 4x plus 16. We want to set that equal to 36. Let's subtract 16. Okay, so we get 4x equals, let's see, 36 minus 16 is 20, I believe. Let's divide by, I'm sorry. Let's, yeah, we can make it, but notice what they say here. Okay, this is me jumping ahead just like sometimes we all do. If x equals 4. So we're actually going to do 4 times 4 plus 16. Does that equal 36? Well, that's 16. 4 times 4 is 16 plus 16. 16 plus 16 is 32. That does not equal 36. Therefore, we're going to say, no, this is not a rhombus. Okay, that should finish this off and give you enough to go on to get started on your homework. Everything should be listed all there together in the instructions so you know what problems you need to do. All right, hope this video was helpful.